welcome to today's session. Today's session, we will focus on the key concepts in machine learning that are very important to be learned before you start your projects in machine learning. So the goal of today's session is I'll try to introduce you to the most of the basic concepts or the key concepts we need to know in machine learning so that in the next session we can start off with some small projects of machine learning. So let's begin. So we know that machine learning is a future of innovation where machine learning is transforming the industries, it is automating the tasks, improving decision making, and unlocking new possibilities. So let's try to understand the complete machine learning landscape in this session. I'll be talking about various key concepts of machine learning which are very important that you need to know before you start your work on machine learning. So the resources of this session is the first book by Tom and Michel, which is a very engineering and mathematical book about machine learning. And the second one is Hands-on Machine Learning with Scikit-learn, Keras and TensorFlow by Aurélien Guérin, which is a very important, very good book. Using this, you can immediately start off with your project in machine learning. So let's begin. So let's first understand what is machine learning. See, machine learning is a science or art of programming computers so they can learn from the data, right? So this is the technical engineering definition that machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. And you can see that machine learning is not something new, right? It started way back in 1950s. And a more engineering oriented definition by Tom Michel in 1997 is it's a computer program which learns from experience E with respect to some task T and some performance measure P if its performance on the task T as measured by performance P improves with experience E. This was by Tom Michel in 1997. So basically to understand this definition in simple terms, we have the program, right? Which actually learns from experience, right? So that experience we're calling as E. And there is some task that has to be achieved, that is task T. So the program is trying to achieve some task T based upon some experiences. And whatever output you get, that you're going to measure, right, in terms of performance, called as P. And the goal is the performance has to be good, it has to be improved. And how do you improve? With experience E. Better you go on giving better experiences. As it E improves, the P also improves. So this is actually another diagram of machine learning, schematic of machine learning system, where we have the learner, we have the reasoner, and this is the model, right? So basically a machine learning system learns from the experience data. Okay, so this is the machine learning system. It learns from the data, which we call it as experience data. And this data is basically experience data basically comprises of the data which we are using to train the system. The data can be anything. It can be an image, it can be a text, it can be some kind of readings. Okay, so you're giving this training data, that is the experience data, to your machine learning system, right? And the learner, then we come to the task or the problem, right? The task T or the problem that the machine learning system is designed to solve. So the system is supposed to solve a problem. It is supposed to solve the task. So it can be anything, right? Which whatever the goal of your work is, maybe you want to recognize some objects in an image, right? That can be a task. It can be the problem. So that is the task or the problem. Next, coming to the model, right? See, model is the core of machine learning system, right? So you have to develop a model. That would be your work, right? And the model can be any mathematical representation. Basically, it will represent the relationship between the input data and the desired output. Okay, so model is the core of your machine learning system. Model is generally represented mathematically. And model, how do you derive it? It will be derived by giving a representation or a mapping between the input data and the desired output. So the model is this model which we develop, right? That would be trained on the experience data. So to the model, we give the experience data, okay, to solve the problem or the task. Now, there is something called as learner here. See, learner is a component that actually trains the model on the experience data. So what is the learner doing? It is training the model. Now you have developed a model, right, in your machine learning system. And now this model has to be trained. So learner will help to train the model using this experience data. Now this usually involves an algorithm. So training is also involves some kind of an algorithm that iteratively will keep on adjusting the model's parameters to improve its performance. Okay. Now learner, right, will have to iteratively adjust, right, in order to learn properly. It has to learn from the data and it has to learn correctly. So there will be an algorithm there where it adjusts the parameters in order to learn better so that it can give an improvised performance. So the result, that what you get is here the performance. So the goal of the machine learning system is to, what we have to do is we have to develop a model, we have to provide the experience data to the machine learning system, and the learner has to learn, right, by adjusting its parameters, learn effectively so that it can give a good performance. And we are, the machine learning systems is model is developed in order to solve the problem or the task at hand. So the performance, right, whatever you get, whatever performance you've achieved may not be good. It has to be improvised. So we give it to the reasoner model, right, where it focuses on improvising the performance again and again, right? So the inputs to the learner would be the experience data as well as background knowledge of the data, and the input to the reasoner would be the problem or the task which we are solving as well as the answer, the performance that we have got. And model is something that we have to develop. It is the relationship, right? It's a mathematical model normally which is giving the relationship between the input and the output. So this is a schematic of a typical machine learning system. Now coming to the some case studies, right? So very first case study we normally take in machine learning is spam filtering, right? So let's say we get a mail, right? And very important that you have to classify the mails to as spam or not spam. Normally what happens in machine learning system, a mail which is not a spam, we call it as a ham. Okay, mail which is not called a spam, it is not a spam, we say it's a ham. So basically you have to classify between spam and ham. So we develop a machine learning model, right, and it will classify either the mail is spam or a ham. Okay, so what are the things that we have to do if you try to map? This is the problem, right? Now we are trying to make a machine learning schematic. Let's try to make a schematic of a machine learning system for this model. So how do you do it? Which is the task here? The task here is classifying the mail as spam or ham. Okay, so as I said, ham means not spam. And then what is the experience? Experience E is nothing but the data, right, that we are going to give. So the emails, which may consist of spam as well as ham. So experience E is nothing but the emails which can be spam, which can be consisting of spam or ham. And what is the performance here? The performance basically can be calculated based upon how correctly the emails are classified as spam or ham, right? Performance can be basically the how correctly, performance basically tells how correctly the emails have been correctly classified as spam or ham. So if you have to talk in machine learning language, the performance P of the program will improve on task T with experience. So the performance will go on improving on this problem, that is a task T, based upon the with experience. As the experience goes on, as you go and give more, as you try to improvise the data or the training data which you are giving in terms of experience E, as you go on improving the experience E, the performance will increase. Okay, so that was the spam filtering using machine learning, using the schematic, which was where we are trying to map this problem to a typical machine learning system. Now, the next question is, why use machine learning? So machine learning we use for various, where are you going to use machine learning, right? Where are you going to replace machine learning, traditional approaches with machine learning? So you can use machine learning wherever you want to automate complex tasks, right? In order to reduce the manual effort and improve the efficiency. For example, spam filtering, fraud detection, image recognitions. It's very popularly used. And we can use it for various other traditional approaches. Machine learning has already replaced various traditional approaches where we were doing image classification, natural processing, natural language processing, and predictive modeling. And machine learning is also very useful in dynamic paces, dynamic environments where the values are like, dynamically changing, where you keep getting new data, where you keep where the model is running continuously in a changing environment, like example, the market analysis, recommendation systems, fraud detections. These are all very dynamic applications. There, machine learning is very good, and it's also very good in data-driven insights, right? So it allows, machine learning will help us to gain insights from large data sets. You're dealing with large, huge amount of humongous, you can say, data sets. Then machine learning is very good. So you have these large data sets, still we can uncover the hidden patterns and find out the trends that might otherwise go unnoticed. Now let's take some two case studies of machine learning approach. So suppose the first one is the spam filtering. As I already told you, you have meals. You have to either classify it as a spam or a ham, right? So coming to the first one, if I use the traditional approach, so this diagram represents a traditional approach. So what happens in a traditional approach, what we are trying to do here is we first examine what spam actually looks like, right? In traditional, we try to examine what it actually looks like, right? Maybe a spam mail will have some kinds of phrases which are very common. For example, credit card, amazing, free. These kinds of words may be very common in a spam. So in traditional approach, we try to look for such common words which are very common in spam mails. Then what we do, we write our algorithm, right? For such kind of mails which are having such commonly used words, right? Credit card, free, amazing, such kind of words. And then we go on testing our program. We repeat it. We test our program for really a spam mail. We also try to test it on a ham mail, that is not a spam mail. So this is a traditional approach. We study the problem, we write the rules, we evaluate, again analyze the errors, we go on looping until we are able to reduce the errors and then finally launch. So that was a traditional approach. In machine learning, what's the difference is the machine learning techniques automatically learns here, right? The difference here is the machine learning model will automatically learn these words and phrases, right, in a spam mail, right? By detecting, it tries to detect, the model will try to detect unusual frequency patterns of words, right, which can be in a spam mail. For example, in a spam mail, the program may be much shorter. It may be having a lot of these words, like which I already told you, like amazing, free, these kinds of words will be there. But here the thing is, the model will try to learn, right, these kinds of mails, these kinds of emails. It tries to learn, and therefore after the learning has been complete, you train. So how do you learn? You train the model, right? How does the learning happen? By training the model. You train the model upon all these kinds of mails. You train the model on spam mails, you train the model on ham mails, and then the model learns, like, okay, these kinds of patterns are existing in a spam mail, these kinds of patterns are not seen in a ham mail. So it learns, and then again you do evaluation of your algorithm, and then if there's a problem, go back, and if the errors are reduced, then you can launch your product. So the difference comes here, right? So in ML, basically it's all about learning, right? Learning from the experience data or the training data sets. The main difference comes here. Now, there's another case study, right? Speech recognition, which is very common. So maybe I have just a program. I just want to talk about distinguish two words, let's say 1 and 2, right? So there's a audio and you have to distinguish these two words, 1 and 2. So you can notice that 2 will start with a high pitch sound called as t, right? So if you're going by a traditional method, you will be hard coding the algorithm, say that when a word starts with a high pitch sound t, then that would be 2. Obviously now there are various ways that people are talking the words, right? You have millions, thousands of words are spoken by millions of people in different styles, in different accent, speaking accent, and lot of noisy environments can also exist, and dozens of languages are there, right? So there are millions of people talking in different styles, so you cannot go and hard code each of these styles. So the best solution here is to give recordings of all these words. So I can give a recording of just this word too, spoken by some thousands of people, and machine learning algorithm will learn all these from all these data sets. I can give I have to give maximum number of ways that this word has been spoken in my training data sets, and the algorithm, the machine learning algorithm will learn, right? It will, you can test the performance, and if there is any problem, you can re-evaluate your algorithm, you can re-evaluate the data set you're giving until you achieve the best performance. So speech recognition is a very important application of machine learning. Okay, so therefore we can say that machine learning is great for so many things, right? This is the machine learning algorithm, just a schematic. How do you do it? You have the problem, you train the model on lots of data, then you get a solution, you inspect the solution, you try to understand the problem. Is there an heavy, your performance is not as good as expected, repeat it, keep repeating, right? You can repeat, you keep repeating the process where you try to give more and more good data sets, or you can try to improve your machine learning model that you have developed. So therefore machine learning is great for various things. Wherever there are some problems which requires a lot of hand tuning, right? There's a long list of rules. Machine learning is good. Machine learning is good for complex problems, right? Where you're not getting any good solution using traditional approaches. There, machine learning is good. Machine learning is good for fluctuating environments where you have a very dynamic environment. It keeps changing. The data set keeps changing, like the market analysis. Then machine learning is good. It's very good whenever you want to get insights into complex problems and large amounts of data you have. Then machine learning is good there. So these are the various applications of machine learning. Use it in autonomous vehicles, for self-driven cars, healthcare, smart assistants, e-commerce. Some of the major projects that you can work on if you are on machine learning, if you want to do is, these are some of the applications that you can take and develop your machine learning model as projects, right? The first one is you can automatically classify the news articles, right? Different types of news articles are there. This is the entertainment section, this is a sports section. You can do that. You can automatically flag offensive comments in a discussion forum. There can be some comments, you can automatically flag them using machine learning models. You can summarize long documents and make it into a short summary. You can create chatbots or personal assistants. You can do forecasting of your company's revenues for next year. You can make your app react to voice commands, right? Take voice commands and react. Detecting credit card fraud, right? You can also use for segmenting the clients based on the purchases, right? Different market strategies for each segment. You can represent complex high dimensional data sets and come out with a clear and insightful diagram. You can do recommendations of products for your client. You can do purchases. You can build an intelligent bot for a game. So these are all small applications which you can choose and start off with some small projects in machine learning. Now, coming to the types of machine learning systems. Now, there are 4 classifications of machine learning systems. These 2 are the major ones, supervised learning and unsupervised learning. So supervised learning means the training data you feed to the algorithm includes the desired solutions, that is the labels. That means you give training data to your machine learning model, right? Now each data has to be labeled. That is a supervised learning. Unsupervised learning means the training data is not labeled. You are not giving any labels to your training data. So for example, I am developing a machine learning model to find out whether there is cancer or not. Okay, if I give all these, let's say I'm giving some kind of mammogram images, right? So if I'm using supervised learning, I'll give mammogram images which are having cancer and say these are the images with cancer. And I'll also give training data of mammogram images which are not having cancer. So that would be supervised learning, where I give labels. In unsupervised learning, I just give of all the images. I give mammogram images with cancer and without cancer, but I don't label it. I don't tell this is cancer, this is not cancer. So that's to learn. Machine learning has to learn, looking at the patterns of the images. The third one is semi-supervised learning, which is actually a combination of about two, supervised and unsupervised learning. Reinforcement learning. Reinforcement learning is basically you have a learning system here, something called, which we call it as an agent, right? The agent will observe the environment and it will perform the actions, right? Based upon the action, right? If it has done a correcting, it will get a reward, and if something is wrong, the action performed is not correct, then it's going to have a penalty. So that's called as reinforcement learning. Let's look into each one of them in detail now. Supervised learning. See, supervised learning is an example. As I already told you, imagine your task is to find out whether the mammogram images you've got are cancer or not. So to your machine learning model, you will give training sets consisting of both. You have to give images with cancer as well as you have to give images without cancer, and you have to label and tell the model, okay, this is the image with cancer. There has to be a label. These are the images without cancer. So supervised learning is about giving data with labels. Okay, so this is what we are showing here. This is a training set. See, these are suppose this is the male classification, right? This is a male, and here I am telling this is not a spam. I'm giving one more thing. This is a male, this is a spam. Okay, so this is an example of a training set, and this is our model. To our model, I'm giving males with spam as well as without spam, and I am telling, okay, this is spam and this is not spam. So this spam, saying spam or not spam, is the label. Okay, now there are two types of supervised learning: classification and regression. Classification is where you just classify, as the word itself says. The output of this model would be, it says this is a spam, this is not a spam. That's the classification. Regression, now the output, basically these are the outputs. Okay, this is the output. In a classification model, the output would be this is a spam, not a spam. That's all. Regression, the output is different. Here the output is a continuous value. Okay, in a regression machine learning model, the output is a continuous value. You can have mileage, you can have age, you can have brands, right? You can have prices of the model. Maybe I have developed a machine learning model where it has to predict the price. Now the price of the car cannot be just two values, right? It can be various values. So that is why this comes under regression. So classification will be like, you can have binary classification or maybe 3 class or 4 class, but it's fixed. You say spam or not spam. You say cancer or not cancer. You say malignant, you say benign. Like that you will have different classes. But regression is you will have a continuous value. It can be the mileage. You want to predict the mileage of a car. Now that's a continuous value, right? You cannot have just one or two numbers there. So that is a regression problem. So this diagram shows a regression. See the output here. You can have various values as outputs like this. So this is a regression problem. The above one is a classification problem where you either say the output is spam or not spam. So that was about supervised learning. Unsupervised learning is just the reverse. See, this is the training data. In the training data, I am not telling that this is going to be a spam, this is not going to be a spam. I just give off all the data. I don't tell. I let the algorithm to find out the patterns in the training. So let's take this algorithm, right? In this diagram, I'm giving some images, right? You can see I just gave the data, but I did not label them at all, right? So it's up to the algorithm. How does it do? There are various ways that unsupervised learning methods work. Various algorithms are there. So one of them is clustering. Like basically it does clusters. So for example here, right, I'm taken a problem of what books the people are reading, right? When you go to a library or to a bookstore, some people, maybe the children come, they go to the comic section. Maybe the teenagers come and they select the books such as science fiction books, right? And some people may select philosophical books. So you just give the training data here, where I'm not going to tell that this person reads science fiction books, this person reads comic books. We don't say it. We just give off all the data, right? And the algorithm by itself tells that 40% of your visitors are reading science fiction books, 20% of your readers are reading philosophical books, and 20% are reading comic books. So basically, how did it do? Here in this case, probably I can use clustering algorithm, where you are clustering, right, the people based upon the uh, interest, right? So for example, when you draw a graph here, feature 1 versus feature 2, these people I put into one cluster, these people I put into one cluster, this I put into another cluster, right? Where I'm saying these percentage of people are reading certain kinds of books. This group are reading a certain kind of a book. This group is reading a certain kind of a group. So one of the methods of unsupervised learning is clustering. In that, again, you have so many types, like hierarchical clustering, where you again within a group I have subgroups, and under that I have subgroups. Now that all comes into the details of clustering algorithm. So one more way of achieving so that's what this is, the clustering which I just told you. One more way of doing unsupervised learning is visualization. You visualize the algorithm, right? For example, here I have tried to make a graphical representation of, let's say, the automobiles, trucks, ships, aeroplanes, all the vehicles, plus the birds, plus the animals. So we have made a visualization of, in a particular area, how many vehicles are there and how many animals are there. And based upon this, maybe you can see, observe here that maybe the wherever trucks are there, I have some birds, sheep. So basically that can be a farm, right? So you try to kind of analyze your algorithm, visualize it by seeing the graphical analysis of visualization algorithm, which we call it as, right? So basically looking into the graphical 2D or the 3D representation of your data, right, the machine learning algorithm will try to make clusters, right? It will separate, okay, this part you have many automobiles, this part you have trucks, this part you have birds, this part you have dogs. And you observe that wherever trucks are there, the sheep is also there. So it can be a farm. So we try to analyze visually using the 2D or the 3D representation of your data. So this is also an example of unsupervised learning, because I did not give any labels to my data which I am feeding to a machine learning algorithm. So this is just a representation. See, this is a supervised learning, right? Where I'm giving labels. I'm saying this is also apple, this is also apple. I'm saying this yellow banana is also banana, green banana is also banana. So I'm giving labels and feeding it to my algorithm. In unsupervised learning, I am not saying anything. I'm just giving off all the images, right? I will not say this is apple. I will not say this is banana. The algorithm has to learn looking at the patterns. So it can be based upon like analyzing various ways of unsupervised learnings are there. It can do on clustering. It can do on visualization. It can try to understand the image. Various unsupervised learning methods are there. Now, these two are types of supervised learning. So this is a classification based learning, right? Classification in the sense where you just classify and say, this is red apple, this is green apple. Maybe I give lot of apple images, and finally output should say this is a green apple or a red apple. So that's a classification learning. Regression is where I will not have two classes like red apple or green apple. I can have a continuous value. So maybe I will say these are the prices of the apples in these areas. So prices can be a continuous value. So that's a regression model. So remember, one thing you have to remember is when you are going into depths of regression algorithms and also classification algorithms, there is one algorithm called as logistic regression. Though this is a regression algorithm, it is commonly used for classification. So this, when you go into depths of regression algorithm, you will see logistic regression and linear regression. Two types of models are there in regression, linear and logistics. Uh, Logistic is commonly used for classification, though it's a regression model. So, and supervised learning algorithms, many of this we will see in the future sessions of this complete tutorial. We will learn about KNN, linear regression, as I said, logistic regression, SVM, very commonly used machine learning model. We'll learn about decision trees, random forest, neural networks. So these are some of the models that we'll be studying in the next few sessions. We'll learn into the depths of each of these algorithms and we'll try to implement it. And also some of the unsupervised learning algorithms also we will learn, like clustering, k-means, hierarchical cluster analysis, PCA, very important concept, principal component analysis, kernel PCA. We will also learn about association rule learning and many more. Okay, so that's it for today's session. Today's session was just a revision of different types of machine learning algorithms. In the next session, we will see a continuation of these concepts, right, of supervised and unsupervised learning. So let's meet in the next session. Thank you.